So, thank you for having me. I'm one of the maintainers of Go Ethereum, but I'm also into Ethereum security. So I'm going to talk to you really quickly about a curious bug that we found while differential fuzzing EVMs. So what we do when we do differential fuzzing is that we generate a state test, which is pre-state. We do a transaction that we apply on it, and we have a post-state. And we execute that into transactions, client under test, and we compare the JSON line streams to see what happens during the execution, and we compare the state roots. A diff in the state root means that we have a consensus issue. Right, and this is a form, we've been doing this in 2017, and basically all the clients support this format. And this standardized volatile state output format basically means that for every opcode that is executed, we see what the PC is, we see what's in the stack, we see what the current depth is, etc. So we can compare what's happening. Right. So what happened when we were executing this? This is a BSU output while executing a generated state test. And it might be a bit hard to see, but towards the end of this, there's a static call happening, and then there are some opcodes, and then you see a lot of Fs, and that is basically the gas. So the gas goes from 0 to near infinite, or -2. So it looks like all of a sudden in a static call, we have infinite gas. And while I was executing this, it turns out we still wind up with the same state root. Because, well, we need to exploit this, right? It can be the same state root because it goes out of gas eventually when we did a return. So, okay, how can we exploit this in order to get a differing state root? This is inside a static call, so we cannot modify the state. It leads to exceptional halt and therefore the same as out of gas. Can we try an infinite loop? Yes, but no, because as soon as we do the jump opcode, it goes out of gas. And it turns out there are only these opcodes that we can play with in this magic static call infinite gas thing. And we cannot do an infinite loop. So even though we're in this cute bug where we have infinite gas to do infinite bad things, I cannot get a consensus issue out of it. So in the end, what we could do is we can make a contract which does repeated static call into another contract. You have the A contract calling into the B contract. And nowadays, doing repeated call into the same contract is cheaper than doing repeat calls to other contracts. So I think it's like 200 or maybe only 50 warm access cost. And we fill this second contract with just some stupid op, like 24,000 not opcodes. So we just flip the stack value 01, 01, 01, 01, 01, 24,000 times, and then it will exit. And in the end, by this method on 8 million gas, we were able to squeeze out 1,350 million instructions performed. So that's 1.3 billion instructions in 8 million gas. So the average gas is 0.006 gas per operation on average, which is like a 24-second block. So we could not make this a consensus issue, but it was a pretty interesting DOS issue in BSU, which they fixed pretty exactly, well, not quite, but 1 year ago, like on November 30, 1 year ago. And this is one of the cases where we put in the fixes like a multiplication speed up to fix in a kind of nice bad issue fix. And that's all I have the time for. Hope you enjoyed it. Thanks. Next speaker.